Football is a game of skill, strategy, and moments of breathtaking beauty. Few sights in sports are as captivating as a perfectly struck free kick curling around a wall of defenders. This mesmerizing trajectory, seemingly defying the laws of physics, is a testament to the power of the Magnus Effect. The Magnus Effect is a fascinating phenomenon that explains how spinning objects like a football interact with the air to create a curved path. This essay will delve into the science behind this captivating force, exploring its history, its impact on the game, and its potential for shaping the future of football. The Magnus Effect is not just a scientific curiosity, it is an integral part of football at every level. For players, understanding this phenomenon can be the difference between sending the ball soaring into the back of the net and watching it sail harmlessly wide. For fans, appreciating the science behind the curve adds another layer of wonder to an already thrilling sport. So let's lace up our boots, step onto the pitch of scientific inquiry, and unravel the secrets behind one of football's most captivating phenomena. The Magnus Effect, though synonymous with the beautiful game, was not initially discovered in the realm of sport. Its origins lie in the 1850s, with a German physicist named Heinrich Gustav Magnus. Magnus was intrigued by an observation made by artillery gunners. Cannonballs often curved away from their intended straight-line trajectories. This deviation, perplexing and seemingly random, had practical implications for accuracy on the battlefield. Magnus designed experiments to investigate this phenomenon systematically. He found that spinning objects moving through a fluid like air experience a force perpendicular to their direction of motion. This force, he discovered, was responsible for the curve of the cannonballs. The faster the spin, the greater the force, and the more pronounced the curve. Magnus's findings had far-reaching implications, extending beyond the battlefield and into the world of sport. The trajectory of spinning tennis balls, golf balls, and of course footballs could now be understood through the lens of this newly discovered principle. What was once a mysterious quirk of physics became a predictable and, importantly, controllable phenomenon, opening up a world of possibilities for athletes looking to bend the game to their will. At the heart of the Magnus Effect lies a deceptively simple interaction between a spinning object and the air around it. Imagine a football spinning counterclockwise as it travels through the air. The air on the right side of the ball, moving in the same direction as the spin, is dragged along with it. This creates a region of low pressure on that side. On the left side of the ball, the air moves against the spin, creating a region of high pressure. This pressure difference is crucial. Nature abhors a vacuum, so air naturally moves from areas of high pressure to areas of low pressure. In the case of our spinning football, this means the air pushes the ball from left to right, causing it to curve in that direction. The faster the spin, the greater the pressure difference and the more pronounced the curve. Similarly, a faster ball speed will also enhance the effect as it interacts with more air. The Magnus Effect is not solely determined by spin and speed. The properties of the air itself play a crucial role. Air pressure, temperature, and humidity all influence the density of the air, which in turn affects the magnitude of the Magnus force. For example, a football kicked at high altitude, where the air is thinner, will experience less air resistance and a less pronounced curve compared to a ball kicked at sea level. Understanding these factors is key to predicting and controlling the flight of the ball. The ability to manipulate the Magnus Effect is a prized skill in football, allowing players to deceive opponents, overcome obstacles, and strike the ball with unparalleled accuracy. Throughout history, certain players have risen to prominence, etching their names in footballing folklore for their mastery of the curve. David Beckham, England's former captain, was renowned for his pinpoint free kicks, often bending the ball around defensive walls with astonishing precision. His technique, honed through countless hours of practice, allowed him to impart just the right amount of spin and power to send the ball on its intended trajectory. Roberto Carlos, the Brazilian left-back, was another maestro of the Magnus Effect. His thunderous free kicks, often struck with the outside of his left foot, seemed to defy physics, swerving dramatically in the air before finding their target with astonishing power. One such free kick, scored against France in 1997, became the stuff of legend, leaving spectators and scientists alike in awe of its impossible curve. These players, along with countless others who have mastered the art of the curve, demonstrate that the Magnus Effect is more than just a scientific principle. It's a tool, a weapon, and an art form. Their ability to harness this phenomenon, combining it with their innate talent and unwavering dedication, has produced some of the most iconic moments in football history. Section 5. Unforgettable goals, from free kicks to corner kicks. The Magnus Effect has been responsible for some of the most memorable goals in football history. These moments, etched in the minds of fans worldwide, showcase the sheer power and unpredictability of the curving ball. One such example is Roberto Carlos's aforementioned free kick against France in 1997. Struck from over 30 yards out, the ball seemed destined to sail wide, veering away from the goal at an improbable angle. However, to the astonishment of everyone watching, the ball curled back dramatically in the air, dipping viciously past the French goalkeeper and into the back of the net. The Magnus Effect is not limited to spectacular free kicks. It plays a crucial role in various other aspects of the game. Corner kicks, for instance, often rely on the Magnus Effect to bend the ball into the penalty area, creating scoring opportunities for attackers. A well-taken corner kick can curl over the heads of defenders and land directly at the feet of a teammate, leading to a goal or a goal-scoring opportunity. Section 6. The wind's influence, how weather shapes the game. Football is a game played in all conditions, from the sweltering heat of summer to the biting cold of winter. The varying weather conditions, particularly wind, can significantly impact the flight of the ball, adding another layer of complexity to the Magnus Effect. A tailwind blowing in the same direction as the ball's trajectory can increase its speed and, consequently, the Magnus force, making the curve more pronounced. Conversely, a headwind can reduce the ball's speed and dampen the Magnus Effect, resulting in a less dramatic curve. Crosswinds, blowing perpendicular to the ball's path, can have the most unpredictable effects. A crosswind can either amplify or counteract the Magnus force, depending on its direction and strength. This unpredictable element can make it challenging for players to judge the flight of the ball, leading to missed passes, wayward shots, and unexpected goals. Skilled players, however, learn to read the wind, adjusting their technique and anticipating its effects to maintain control over the ball. Section 7. Mastering the technique, foot placement, body positioning, and timing. Mastering the Magnus Effect is not merely a matter of brute force. It requires a delicate touch, precise technique, and an understanding of the underlying physics. To generate spin, players must strike the ball off-center, using the inside or outside of their foot to impart a rotational force. The angle of approach, the part of the foot used, and the follow-through all influence the direction and speed of the spin. Foot placement is only one aspect of the equation. Body positioning plays a crucial role in generating the optimal launch angle and power required for a curving shot. Timing is another critical factor. Players must strike the ball at the precise moment to generate the desired spin and trajectory. Striking the ball too early or too late can result in a weak shot or an unintended direction. Mastering the Magnus Effect, then, is a testament to a player's skill, athleticism, and understanding of the subtle interplay between force, spin, and air resistance. Section 8. Debunking the myths, separating fact from fiction in football physics. The Magnus Effect, though well understood in the realm of physics, is often surrounded by misconceptions and myths, particularly in the context of football. One common myth is that the Magnus Effect only affects spinning balls. While spin is crucial for generating the Magnus force, even a non-spinning ball can experience a slight curve due to its interaction with the air. This phenomenon, known as the knuckleball effect, occurs when the ball's seams disrupt the airflow, creating unpredictable movements. Another misconception is that heavier balls curve less, While it's true that a heavier ball requires more force to move, its mass also means it's less susceptible to air resistance. Therefore, a heavier ball, once set in motion, can maintain its spin for longer, potentially leading to a more pronounced curve over a greater distance. Understanding these subtle nuances and debunking common myths is crucial for players and fans alike to appreciate the true complexity and beauty of ball physics in football. Section 9. The future of the game: innovation and the Magnus Effect. As technology advances and our understanding of the Magnus Effect deepens, we can expect to see its continued influence on the future of football. Ball design in particular is an area ripe for innovation. New materials, textures and seam patterns could be engineered to enhance grip, reduce air resistance, and create even more unpredictable trajectories. Imagine a ball that curves later in its flight, deceiving goalkeepers and defenders alike. Data analytics and wearable technology are also poised to play a role. Sensors embedded in balls and players' boots could provide real-time feedback on spin rate, launch angle, and other variables, allowing players to fine-tune their technique and optimize their performance. Virtual reality and augmented reality could create immersive training environments, allowing players to experiment with different techniques and experience the Magnus Effect in a controlled setting. Section 10. Conclusion: the enduring allure of the bending ball. The Magnus Effect, a seemingly simple interaction between a spinning object and the air, has had a profound impact on the beautiful game of football. From the iconic free kicks of Beckham and Carlos to the unpredictable swerves of a wind-affected shot, this fascinating phenomenon continues to captivate players and fans alike. Understanding the science behind the curve not only enhances our appreciation for the skill and artistry on display, but also opens up exciting possibilities for the future of the sport. As technology advances and our knowledge deepens, we can expect to see even more innovative applications of the Magnus Effect, leading to new techniques, enhanced equipment, and even more breathtaking moments on the pitch. The quest to master the curve, to bend the ball to one's will, is a testament to the enduring allure of this fundamental force of nature and its captivating influence on the world's most beloved sport.